From the EDM Design Cockpit, we can view the structure for the D Redbox system design. This multi-board project contains the system design and two PCB designs. Notice that the two PCB designs contain individual schematics and individual layouts. Let's start by opening the system design. Xpedition System Designer is used for capturing and managing complex system interconnectivity. When we first open System Designer, we are presented with the System Architecture view. Here we see that the system is comprised of four functional areas: computing, hub, interfaces, and memory. We can push into one of the system architecture blocks to view the logical design. Switching to the blocks view, we can see the various blocks contained on each PCB. System engineers can easily expand the blocks listed in the Navigator window and cross-probe to the canvas. Switching to the boards view, we can see the two PCBs within the system, DBMC and DTE tray. A closer view of the system shows the interconnects between the two PCBs. The two PCBs are interconnected via connectors on each board, X3001 and X600. It is of course important to always ensure that information is properly synchronized between the tools utilized in the design process. The synchronization status between System Designer and the PCBs is easily reviewed by using the Manage Boards functionality. Signal connectivity between PCBs is also easily reviewed within System Designer. Here we use the Signal Manager to review the signals between the two connectors. Notice that the connections at pins A33 and A34 are reversed and as such are highlighted in red. Using the Signal Manager, we can easily resolve the issue by swapping the connections using the drop-down listing of signal names. We will swap the pins on the DTE tray connector. Of course, now these updates to the DTE tray signal names need to be pushed to the PCB. This is reflected in the Manage Boards dialog. As such, we will select Push Datasets to PCB. The system design is automatically checked back into EDM as part of the synchronization process. Back in the EDM Design Cockpit, we will check out the schematic for the DTE tray design. Xpedition Designer clearly conveys to the user that there are changes from System Designer that need to be forward annotated. The Synchronization Assistant can be used to review the pending forward annotation changes and then apply them to the schematic. Here we see the swap of pins A33 and A34 from System Designer are waiting to be applied to the schematic. The changes can then be checked in. At this point, the layout must be checked out in order to forward annotate the changes from the schematic. Once checked out, simply select the yellow traffic light within Layout and the forward annotation process begins. Upon completion of forward annotate, the system design, schematic, and layout can all be checked back into EDM. We are now ready to analyze the system design. Specifically, we want to use Hyperlink's multi-board signal integrity analysis to evaluate the quality of a transient signal as it is transmitted from driver to receiver across the two PCBs. In order to open the multi-board simulation pack created by System Designer and Hyperlinks, there is a dedicated command available in EDM Design. Once it is selected, Hyperlinks is invoked. Within Hyperlinks, we will select the net that we are interested in simulating. We will then run an interactive simulation. The digital oscilloscope form allows the SI engineer to set options for the type of operation, the stimulus, and the type of measurement to be performed. When ready, the engineer simply selects Start Simulation to perform the analysis. Upon completion of the multi-board simulation, the results are clearly conveyed on the digital oscilloscope. Hyperlinks SI has the ability to simulate SIR-DES signals using an IBIS AMI channel analysis. The IBIS AMI channel analyzer uses a wizard to step the engineer through the steps of selecting the types of analysis, setting up the channel characterizations, configuring the AMI models, and then running the analysis. The results of the multi-board analysis are stored in EDM for easy viewing by any team member. Simply open the System Design Properties and scroll to the Hyperlink's Multi-Board Net Simulation Results section.